Hi everyone. So we all know that for physicians, one of the scarcest resources is time. And we also experience, some of us also experience that patient journey or patient experience in hospitals is not always the best. So we tried, I have the pleasure to represent the Tender Summit team today, and we tried to address these two topics and leverage artificial intelligence to one, try to assist physicians to diagnose lung pathologies through X-rays, and also try to automate coordination between diagnostics tools and CRM tools in hospitals to propose personalized appointment for patients' follow-ups. We believe that our solution would help physicians focus on what really adds value rather than spending their time, a sixth of their time on administrative tasks. Without further ado, let me show you a bit more of our solution. So the first module is really to use artificial intelligence to detect up to 14 different pathologies from X-rays. From there, we integrate clinical observations to try to refine further the diagnostic. And the second step is to link the diagnosis to the hospital CRM to make sure that the next available time slot for the patient who needs it the most is actually reserved for this patient. We believe that this solution is able to optimize the physician's calendar and match his next available time slot to the patients that needs it the most. And for patients, it's access to a faster and more efficient diagnosis. Let me just show you in a quick example. If you want some detail on the code, we'll be happy to share some more. But basically, for a patient, you have different, for a physician, you have different patients with different radiology exams. And then kind of depending on when the physician is available and when you got the result of the X-ray, then you get a follow-up appointment. But maybe for instance, in this case, patient C would have benefited from having an earlier appointment because his disease was the one who had the highest priority versus other patients who were scheduled before. So we believe our solution is able to help the physician get a quicker diagnosis and also make sure that the patients who needs it the most is actually seen the first. Thank you for listening. We're happy to open for questions.
Is there any way to diagnose earlier cystic fibrosis from your X-rays in young patients, by the way? Cystic fibrosis. Can you identify cystic fibrosis earlier with an X-ray examination?
Well, I don't really understand.
So you don't see.
The 14 pathologies do not include.
Don't include. Okay, that's right.
It was more the region, edema, pneumonia, pneumothorax.
Good, clear.
So thank you very much for your presentation. It's very interesting. Actually, this is a daily problem that all the patient and the medicine they face this, and I'm sure that maybe some of you had experienced this, and I know people that experience this. The time that it takes to go to a pulmonolog and even come get the result, and then the suivi after, it's quite troublesome. So basically, it's interesting to have a system that can once we have the X-ray data, it can do a preliminary detection or at least identify the zone of interest like how we do in image processing with the CNN network, and you can at least because sometimes it happens that there are some zones in the image that are ignored or maybe overlooked, and this can help to increase the efficiency and accuracy of the diagnosis with the medicine, of course. But then you have to integrate it. It's a really daily problem. So I saw that you were working on some image analysis. So do you have a live demo? I mean, what happened? Did you manage to at least make your neural network work?
Yeah, so started putting things together yesterday and probably hassle, but yes, we now have a live demo. We have a neural network development. Basically, it's based on Stanford's chessboard. Textbook's paper published 2 years back.
Okay.
They later published something in 2019. So they used something.
They used a DenseNet, which I felt was they were using one thing for so many things, and they got a decent AUC score. But my idea was using 5 different networks. When you have a principal network, which further narrows down into 4 different networks. So you have a principal network pointing towards either lung opacity, towards oh yeah, so here it is. So basically, we had the main data set, and I wanted to try something else. It's divided into like 5 different parts, and on the main data set I had a ResNet worked out on it, and then basically the ResNet says, okay, this is more related towards lungs, lung opacity. So then these ResNets that were trained on lung opacity data sets, they're more capable of detecting such types of yeah. So that was my approach. But given the lack of compute power and given the lack of time, I could not really achieve what I was looking to achieve. But I feel this is how you're supposed to approach problems of 14 categories, and not really. It's never as simple as a cat and a dog. It's not like 0 and 1. We have different cases. So this is our approach. This is our pipeline. I just took some more time to put it together and bring it to life.
Congratulations, because this is really interesting, because that's the main problem nowadays, because neural network are trained for general purpose and
right.
Not specialized. So if you want to use the same network for detecting different diagnostic, your score might be changed based on different conditions.
Right.
So using a cascaded neural network, that you can have a screening first, and then send the result to a more specialized neural network.
Correct.
I think it really helps to increase the accuracy of the diagnostic
True.
for specific condition. I think that's a nice aspect. It's understandable that if you don't have computing power and GPU system, it's difficult to train for each of them. But you could have done at least for one of them?
So the thing is that the idea was that it would all work only if we had 4 working models. Actually, it's trained right now. I just didn't put together the inference script. It's a little complex putting together inference script, because it's a little tricky as to, you have a label, of course, given what he might have many diseases. He might have 3 or 4. So the tricky part was making sure that you detect at least 2 to 3 diseases, because that is mostly the case. So it was just kind of, I was up all night, and I was just my head was going mad seeing all these lines of code, and it took me some more time, but I was not too far away from putting the inference code, and could have got something interesting out of this. But it was just aim small, miss small. That was the idea.
Very quick question. Congratulations for your project, guys. Is your tool supposed to replace radiologists?
That's far from what we're trying to do here. It's just a helping hand. We know all you radiologists work very hard every day, and this is just to ease the pain or the workload all of you guys are going through. We understand it's a problem in France. All of you are just burdened with a lot of workload, and this is just a helping hand. Please not take this as anything apart from that. Yeah.
Just add to this, we said something about priorities and some patients being more urgent than others. It's the doctor who gives this information. as well as the dates for scheduling. We can have a system that tries to learn from experienced doctors and build a recommender system for novice radiologists so they can have transfer of skills much faster. So that could be done too.
Just adding something quick, you could add the input of the medicine